Hello there, I'm Ethan Hull from PHDS. I'm here to talk to you today about GeGI, the Germanium Gamma Ray Imager. GeGI is a one-stop gamma ray solution. Inside this small yellow box is a pixelated germanium detector, electronics, a mechanical cooler, and software application necessary to make the highest fidelity gamma ray measurements possible. So now we're going to take GeGI, operate it on its battery for a little while, and go see about making some measurements. Alright, so here I have my GeGI. Now imagine for a minute that I just came into a situation I know nothing about. I have no idea which radioisotopes or which gamma ray lines to expect. GeGI can tell me all about that by pressing a single button here. So now we have a close-up view of our tablet on the side of the GeGI. Push the start button and see gamma ray energy spectroscopy coming in. In a few seconds I can see that I've identified the cesium-137 peak at 662 keV. Now, GeGI also has spatial resolution in the detector. That spatial resolution allows me to calculate this Compton gamma ray back projection. You can see this spot here that we then superimpose on the optical image from the camera to acquire this location information. So we've been able to identify and locate cesium-137 source here. You can see it appears to be in this object in the forward field of view. Okay, so GeGI indicated we have a cesium-137 source in this object, and if I pick up this cup, indeed I find that I have a cesium-137 source. So as we have seen, GeGI has indicated the location of cesium-137 source. Now it turns out that that cup is about 1 meter away. Put that information in here and then highlight the source. It tells us we have about 45 microcuries of cesium-137. So we've been able to identify, locate, and quantify the radioactive situation. So with our GeGI in the same situation, we've counted just a few minutes longer and managed to see a very weak barium-133 peak down here at 356 keV. Now if we do our Compton gamma ray image of that peak, GeGI tells me that that source is behind this door. So GeGI indicated earlier that we had a cesium-137 source here. Upon counting a little longer, we think that we have a barium-133 source somewhere in this region here. So if we investigate a little further, we find that indeed we do have a barium-133 source right here on the other side of this wooden door. So now we believe that we have a barium-133 source here behind this wooden door. Now, the distance to that door is a little over 2 meters. So we put that distance here. We enter the fact that we're coming through about 7 centimeters of wood. And then we highlight that region of interest. GeGI tells us that we have something like about 21 microcuries of barium-133 there. So again, we've identified, we've located, and we've quantified the radioactive situation. Okay, so now we have seen how GeGI can come into an unknown situation and locate the various radioisotopes. Now, if we do find a concentration of some radioisotope, say in a barrel, and it's got a complex shape or a shape that we want to understand more, that's where we want to operate it using the pinhole aperture here. I'm going to show you how we do that now. So we simply take the GeGI around and place it into this tripod. Alright, so now we have the GeGI installed in the pinhole aperture tripod. So we've got some lead here. We've got a 2.5 centimeter thick piece of lead with a 60-degree, 1 millimeter diameter pinhole directly over the center of the detector. And then some shielding around the side here. The detector actually screws into this support so it can't fall out of here. What we've got over here is piece of plywood and some hidden gamma ray sources back here. So GeGI is going to try to image through the plywood and determine what is there, identify it, locate it, and quantify it.
So as we saw before, here we have the gamma ray spectroscopy from the GeGI detector, and we can see we've got gamma rays detected from 2 cobalt-57 lines as well as a 81 keV line from barium-133. Previously we were focusing on the Compton image, but now since we're interested in the features, geometric features of this source, we'll go into this pinhole image now that we're looking through these this 1mm pinhole. And you can see here we've got 3 hot spots that are showing up in our field of view, which is covered by this piece of plywood. We can go through these. Here is the 122 keV line image from cobalt-57, as well as the 136 co-located, and then also that's the location of the 81 keV line from barium. Now to find out how much of each source may be there, we can just select a region of interest around each source, 1, 2, and 3, and we see that there's roughly 22 microcuries of cobalt-57 here in region 1, about 20 microcuries of cobalt-57 here in region 2, and around 16 microcuries of barium-133 here in region 3. And so now we've seen that we can, in a detailed way, show the distribution of these isotopes, and if we take off this piece of plywood now and look at what was behind them, I'll just quickly remove those regions of interest and take a photograph, and you can see that these hotspots overlay directly on the button sources that were located behind the plywood.